So here we're going to look at finding empirical formulas from mass percentages or masses. An empirical formula is just the lowest whole number ratio of different atoms in a compound. So what's an example of an empirical formula? An example would be, let's say, NaCl. Right? That ionic compounds are going to have almost always empirical formulas is the formula. So the lowest whole number ratio of sodium to chlorine here is 1 to 1. Let's see, water, H2O, right? It's 2 hydrogens for every oxygen. That's an empirical formula. It's the lowest whole number ratio. But we can find some molecular compounds that don't have the lowest whole number ratio, or where the ratio can be reduced. Quick example, just hydrogen peroxide. Right? Hydrogen peroxide is H2O2. So we see that's not the lowest whole number ratio. The empirical formula will be HO for hydrogen peroxide. So this is a molecular formula. This is an empirical formula, and we'll talk about these in a different video. But empirical formula, just lowest whole number ratio of one atom to another. So if you are given a mass percentage, if you're told, okay, we've got a compound and it's 50% by mass this and 25% by mass something else, whatever. If you're given mass percentages, you can figure out the empirical formula of the compound. Or if you're given the masses. So if for example, you're given a sample, you say you have a 10-gram sample and 3 grams are this element and 7 grams are this element. You can figure out the empirical formula. You just need a periodic table. So step one, we are going to convert masses of each element to moles. No problem, one-step conversion. And then number 2, we're going to find the lowest whole number ratio of each element. So from mass percentages, if you're given a question, and I'll cover up all this stuff. If you're given a question and they tell you, oh, it's 35.51% carbon, 4.77% hydrogen, 37.85% oxygen, 8.29% nitrogen, and 13.60% sodium. If they told you that, you say, okay, I know the percentages. So the way I like to do it is I like to say, oh, well, if I had a 100-gram sample, that would be how many grams there are. So, okay, now I've got 35.51 grams of carbon. I just took the percentage, made it a mass. You can see the mass of hydrogen, oxygen, nitrogen, and sodium. It's all just the percentages that I just named changed to masses. So we've got masses, right? That's the thing. But step 1 here, if we're finding empirical formula, we need a mole ratio. So we need to figure out if we've got 35.51 grams of carbon, well, how many moles is it? So we use the molar mass of carbon, 12.01 grams. Grams is going to cancel. Now we get 2.957 moles of carbon. Hydrogen, we use hydrogen's molar mass, which is 1.008 grams per mole. We have 4.732. Please don't round this. Don't round this too much. You want to keep as many digits as you can. It might look like you're keeping extra numbers. Extra is not going to mess you up. If you rounded this to 5, you'd have a problem later, and you'll see. So keep 4. Keep 4 numbers there. We've got the oxygen, divide by 16, we get 2.366. Nitrogen, we get 0.5917 moles. And sodium is 0.5916. So we have all these number of moles. Is a mole ratio for carbon, hydrogen, oxygen, nitrogen, and sodium. But when we write a formula, we never write some decimal like this. Right? When we say carbon dioxide, we say CO2. It's 2 to 1. So we want whole numbers. We don't want 0.59 or something like that. So once we have moles, we do step 2. We find the lowest whole number ratio of each element. So we know the mole ratios. What we want now is the whole number mole ratio. And to do that, you pick the lowest one. First what you want to do is pick the lowest one and divide all of the number of moles by that lowest one. So the number of moles of sodium is the lowest, 0.5916. We divide everything by that. And you notice for carbon, we get 4.998. That is very close to 5, and we can round that. For hydrogen, we get 7.999. That is very close to 8. Right? So we got 5, we got 8. Oxygen, 3.999, very close to 4. And these are just 1. So if we're going to write the empirical formula of this, and I'm just going to go in the order of the elements as they were given, we would write carbon is 5. Let's see, hydrogen is 8. I'm just going in the order that they've given it to us. Probably the sodium should be out in front. This looks like an ionic compound with maybe some polyatomic anion here, and the sodium out front. But we have 5 to 8 to 4 to 1 to 1. This is your empirical formula. Okay, that's the first one, and that was from mass percentages. The mass percentages make that mass, convert to moles, divide by the lowest, and it worked out. We had whole numbers after we divided. So I'm going to get rid of this. Next one is from masses. Right? You could analyze a sample and say, oh, I know this sample has this many grams of phosphorus, 1.347 grams of phosphorus and 1.744 grams of oxygen. Well, I have masses, so we're going to do step 1. We're going to convert masses to moles. We use the molar mass of phosphorus and oxygen. All right, we get 0.04349 moles of phosphorus, 0.109 moles of oxygen. The next one was 0. And we divide by the lowest one, the lower of these, which is the phosphorus. So we get a 1 to 2.5 ratio. You'll notice, well, that's not a whole number. So what we're going to need to do now is to scale it up. How would we make this 2.5 into a whole number? Well, we double it. So we double both. And we get 2 to 5. We should come up with an empirical formula of P2O5. All right, so this is our lowest whole number ratio. We don't want to put a decimal.